Hey guys, back for round two. Okay, we're going to have a video this time giving you a review about exponents. Okay, so you have one about properties and now you have one about exponents. And again, I'm going to kind of talk you through a PowerPoint. And let me remind you, you need to take notes, just as if you were in class. So write these rules down, write the examples down. That way on a pop test, sometime I might just say, pull your notes out and copy me down the example I gave you on the video about rules of exponents where you're multiplying with the same base, and give me the example I gave you on the video. So you're going to need to take notes to be prepared for your pop test. Okay, so again, we're going to share this screen with you, all right, and kind of talk you through my examples. All right, and again, I know you know all these. It just makes me feel better for you to have them to refer back to, just in case it's been a while. All right, so here are our exponent rules. Now remember, when you have something like 2 to the third power, the big number on the bottom is called your base, and the superscript at the top is called your exponent. So here, the 5 is your base, and the 2 is your exponent. Okay? Now, what that does, remember, is the base is the number that you're actually multiplying. So 5, a bunch of 5s. How many times? 2 of them. So 5 to the second is 5 times 5. And 5 to the fourth means you multiply 5 by itself 4 times. So in this rule, notice the bases match, A and A. Okay, if the bases don't match, this rule does not apply. Okay, now the exponents, the superscripts do not have to match, but if you're multiplying and the bases are alike, you simply add the exponents. That's what that rule means. So 5 to the second times 5 to the fourth would be 5, and you add the exponents. 2 plus 4 is 6, so I get 5 to the 6th. Now you can't do it the long way. So I've got this down here to show you why it works. You know, 5 to the second was 5 times 5. 5 to the fourth was 5 times 5 times 5 times 5. So I've got a bunch of 5s multiplied, so the base is 5, and I've got 1, 2, 3, 4, 5, 6 of them, 5 to the 6th. So that's why the rule works, but isn't that a whole lot faster if you just know the rule? Okay, look what happens when you're dividing with the same base. So again, these bases have to match. See, a 6 and a 6, okay? Now, the shortcut is the top exponent minus the bottom exponent. It's not big minus small. It's top exponent minus bottom exponent. So that'd be a 4 minus a 3 would give you 6 to the first. And of course, you know 6 to the first is just 6. And again, why does that work? Well, 6 to the fourth means 6 times 6 times 6 times 6. 6 cubed is 3 of them. So any number divided by itself, except 0 divided by 0 is 1. So 6 divided by 6 would divide out to 1 here and here and here. So on the top, you'd have 1 times 1 times 1 times 6. Remember that identity property of multiplication says 1 times 6 stays 6. And multiplying 1 times itself gives you 1. So that's the reason it works. Now remember, make sure you understand, it's top minus bottom. Because those are both 2s, that base is a 2, and it's 3 minus 7, which is a negative 4. And we'll talk in a minute how to simplify 2 to the negative 4. Now, what happens if you have multiple things in the parenthesis and they're multiplied? So you've got a product to a power. Okay, this doesn't work if it's a plus or a minus, but it works if there's a product or if there's a division. Okay, that exponent goes with everything inside that parenthesis if it's multiplication. So a to the m times b to the m. So if you had 2x cubed, that 3 would go with the 2, so I'd have 2 cubed, times that 3 would go with the x, and I'd have x cubed. Remember, 2 to the third means 2 times 2 times 2. So 2 times 2 is 4, and then 4 times 2 is 8. So that's why I get 8x cubed. So 2 to the third isn't 6, okay? Now, why does that work? Remember we talked about before, an exponent goes with what immediately precedes it. Well, what precedes this 3 is this parenthesis. So I have 3 of these parentheses. So a 2x times a 2x times another 2x. Now remember, when you don't have anything between them, you've got multiplication. And remember, by that commutative property of multiplication, I can change the order. And by the associative property of multiplication, I can change the grouping. So I change the order, and then I change the grouping. So I change the order and put all the 2's together and group them together. And then I change the order by commutative property. And then I change the grouping by the associative property and group the x's together. So 2 times 2 times 2 is 2 to the third, which is 8. And then x times x times x is x cubed. So that's doing it the long way, but that's why it works. All right, similarly, it works the same thing on division. That exponent would go with the numerator of a and with the denominator of b. So if I had 4 over y squared, the 4 would be squared, and also that denominator y would be squared. So I'd get 16 over y squared. Now what happens if you have a power raised to a power? That's when you multiply them, okay? So when you're multiplying, you add the exponents. When you've got power raised to a power is when you multiply them. So if you have 4 squared cubed, then you'd multiply that 2 times that 3 and get a 6. Okay, and here's why. Remember, what does 4 squared mean? Well, it means 4 times 4. And I've got 3 of those. So I've got a 4 times 4 and another 4 times 4 and another 4 times 4. I have 3 of them. How many do I have? 1, 2, 3, 4, 5, 6. 4 to the 6. So if you ever get confused about when do I multiply the powers or when do I add the powers or when do I subtract the powers, you can always do it the long way, okay, to verify the rule for yourself. So start learning those shortcuts unless you want to work them all the long way. Okay, what happens if your exponent is negative? Well, it really works if it's negative or positive, but we want to have positive exponents to be in simplified form. So when you have a base to a negative exponent, if you move a term from numerator down to denominator or denominator up to numerator, the sign of the exponent changes. So because it was negative, when I moved this, remember this is really over a 1. So if I moved it to the denominator, it becomes the positive m. Now, it's not the sign that changes of the term, it's the sign of the exponent that changes. So 2 to the negative 3 is the same thing as 1 over 2 to the positive 3. And then, of course, what does 2 to the third mean? Well, it means 2 times 2 times 2, which, of course, gives me 1/8. So this x to the negative 2, if I moved it from numerator to denominator, all right, then I would be able to change that sign and have 1 over x squared. So we don't want to leave negative exponents. So go back up here. Okay, go back to where we're here. I wouldn't leave it 2 to the negative 4. Okay, what I would do at that point is I would, let me make sure we're clear about something. Okay, so do we understand that this means 2 to the negative 4 over a 1? So this 2 to the negative 4 is in the numerator. So if I move something from numerator down to denominator, I change the sign. Okay. So that's going to become on the bottom now, that's going to become a 2. And then the sign on that 4 changes from negative to positive. And then I have a 1 left on the top. So 2 to the negative 4 is the same thing as 2 to the positive 4. Okay, is that clear? All right. So I need to clear that drawing, and then I'm going to move back to where I was. Okay, just to make sure that we're clear. All right, so that's kind of our basic rules there. All right, so let's kind of get rid of that. Let's see what we've got. Let's undo that. Try to come down to the next slide. Let's see why it doesn't want me to do that. All right, format, maybe, clear. Let's go down to this and see what will happen. Let's go back to the mouse. There we go. Now it's happy. Technology, don't you love it? Okay, so now let's go to our next slide. Okay, let's make sure we understand the relationship between roots and exponents. All right, so, all right, let's try to get what we've got again. All right, so if I've got an exponent, that's called your index number. All right, and this is your base again, you know that's your exponent. So that A is the base and that N's your index number. So if the way you change it from roots to powers is that A to the B, that B is the denominator. I mean that that B is the numerator and that N is the denominator. So your index number is always the denominator. So what do I mean by that? Well, first of all, when there's not a root showing, it defaults to a 2. That means square root. So that's how I know my index number is a 2. If it's not a 2, the number's got to be showing like this 3. All right? So remember, there's not an exponent showing on this 9, but we know what the exponent is. All right? The exponent's a 1, so that's why it's 9 to the 1/2. That power is my numerator, that index number is my denominator. And of course, the square root of 9 is 3. Okay? Because 9 is 3 squared. And then 2 times a 1/2 would be 2 to the 1st. So we'll work a couple in class to make sure you're clear. Same thing here. That index number is always my denominator. That power is always my numerator. So the cube root of x squared is x to the 2/3. All right. Let's go back for a second. That 2 goes with everything. So that's an index number of 2. So that's a 4 to the 1/2, an x to the 1/2, and a y to the 1/2. Okay, well, 4 to the 1/2 is 2, and then x to the 1/2 is like the square root of x and the square root of y, so that it just stays 2 times the square root of xy. Similarly, that index number is a 2, so that whole thing is to the 1/2. So if you'd rather do the whole thing first to the 1/2 and then distribute, you can. Remember, power raised to a power. 5 times 1/2 is 5/2. 16's to the 1st, so 1 times a half is 1/2. Okay, and then again, this y to the 6, well, 6 times 1/2 is 6/3. So you can either take that index number with these this way, or you can change the whole root to a power and use one of your exponent rules from last time. So make sure that you're comfortable with roots. Now, if you're not comfortable with numbers and roots, let's make sure we're clear about something. Some people get confused. There's a rule that says the square root of a times b is the square root of a times the square root of b. So one way, when you were in high school, they told you to think of the biggest root that was a factor. So 48 is 16 times 3. So I can turn that into the square root of 16 times the square root of 3. Well, the square root of 16 is 4, so I'm left with 4 times the square root of 3. But some of my students have a hard time with that. So here's a way that I kind of created a little bit. I don't remember if I found it somewhere, whatever. So what you can do is go back to, 4th grade and do a factor tree. Remember what a factor tree is. You write down any 2 factors except 1 in the number, and you keep breaking it down till you get all prime numbers. So 48, you could use 2 times 24, you could use 6 times 8, you could use 24 times 2. You pick any pair that multiply together to give you 48. If it's prime, you bring it down. If it's not prime, you break it down. Remember what prime means, has exactly 2 factors, 1 in that number. Well, see, 6 isn't prime, so I break it down. What gives me 6? 2 times 3. Well, 8's not prime, so I break it down. What gives me 8? Well, 2 times 4. Well, now 2 is already prime, so I bring it down. 3 is already prime, so I bring it down. This 2 is prime, so I bring it down. But see, 4 is not prime, so I break it down. 2 times 2. How do you know when you're finished? When everything on the bottom of the tree is prime. So then I can come back over here, and basically, if the index number is a 2, then you circle them in pairs. If it were cubed, I'd have to have a triple that matched. And the rule is, when you bring the pair out, you only write down what's in it once. So when I bring that pair out, I only write down what's in it once. When I bring that pair out, I only write down what's in it once. And the numbers outside get multiplied together, and the numbers inside get multiplied together. So what if you have variables? You could do it the same way. 6 is 2 times 3. Well, what does x to the 4th mean? Well, it means x times x times x times x. You got 4 of them. And then you got 3 y's. Well, see, because the index number is a 2, you got to circle pairs that match. There's a pair of x's and a pair of x's and a pair of y's. So when you bring that pair out, you write down what's in it once, x. When you bring that pair out, you write down what's in it, x. You bring that pair out, you write down what's in it, y. So that's what's on the outside and what's left on the inside. So what's on the outside gets multiplied together. Well, x times x is x squared. And x squared times y, we write just x squared times y. And then 2 times 3 times y is 6y. So you could leave it this way, or you could do it this way. Order of operations doesn't make any difference. Remember, excuse me, your order of multiplication doesn't make any difference. And usually we basically take numbers and usually put them in front. So that's why I separated that square root of 6 to the square root of 6 times the square root of y. And then that commutative property of multiplication allowed me to change the order. So if you need some more help with exponents, then what you're going to need to do is you're going to need to come see me. Okay, so you can shoot me an email. We can Zoom one-on-one, have a meeting. I'm going to give you some homework problems and let you just practice. But if you have any trouble, just let me know. So hopefully that'll be helpful for you.